Welcome to today's Explainer. All right, we're going to totally shift how we look at the world around us today. We often think of the Earth as just a static, giant rock that we just happen to live on. But actually, scratch that. We are going to reframe that completely. We need to look at the Earth as an ongoing, massive art project, a masterpiece that is constantly being sculpted, both from deep inside its fiery core and from the outside elements that weather its surface. I mean, it's a serious question. Is the ground beneath your feet actually as solid as you think it is? We step onto the pavement or walk through a field, and we just take for granted that the earth is fixed and unmoving. But the reality is we're actually standing on a restless, constantly moving machine. The surface of our planet is not some single, unyielding shell. It's dynamic, it's alive in a geological sense, and the forces driving it are both terrifyingly powerful and incredibly beautiful. So here's our roadmap for today. First, we'll cover the restless Earth, then weathering and erosion explained. Next up, nature's sculptors at work, and finally, when landforms turn deadly. Let's get right into it.
Okay, let's dive into this. Section 1, the restless Earth.
So our planet's composition is beautifully layered. Right in the center, we've got the core, making up about 22% of the Earth's volume. It's basically this extremely hot, spinning metal ball. Above that is the incredibly thick and hot mantle, split into upper and lower sections, which together make up a massive 54%. And then there's the crust. That's the remaining 24%. The crust is the outermost layer. It's the very ground we build our homes, our cities, and our entire civilizations on. And it's kind of wild to realize that this space we call home is just a piece of the puzzle, floating right above those incredibly hot, semi-molten layers underneath. Which brings us to a total game changer in Earth science, plate tectonics. This theory, championed by W.J. Morgan, explains that the crust and the upper part of the mantle form what we call the lithosphere. But, and this is absolutely crucial, this lithosphere isn't a solid, unbroken shell. No, it's fractured into these massive, solid rock slabs known as tectonic plates. Beneath these plates is the asthenosphere, a hot, semi-molten layer. Because of all that intense heat and movement down there, these massive tectonic plates literally creep along. I'm talking at a speed of just a few centimeters a year. Think of this deep earth movement as pushing up the raw clay for our master sculptor metaphor. It provides the very material that creates our landscape. Now, since these plates are always moving, they inevitably crash into each other. And they do this in three main ways. First up, convergent boundaries. This is where plates collide head-on. When two continental plates smash together, they literally fold the Earth upward, creating massive mountain ranges like the Himalayas. If an oceanic plate collides with a continental one, it sinks below, melts, and sparks violent volcanic activity. Second, we have divergent boundaries, where plates pull apart, like at the Mid-Atlantic Ridge, allowing magma to rise up and form brand new crust. And third, transform boundaries. This is where plates slide horizontally past one another. They grind, they catch, and when they slip, massive earthquakes. The San Andreas Fault is a classic example of this. In fact, most of this intense, terrifying activity is concentrated around the perilous ring of fire that surrounds the Pacific Ocean. Moving on to Section 2, weathering and erosion explained. Now, what's really interesting about this next concept is that people confuse these two things all the time, but weathering and erosion are absolutely not the same thing. Weathering is the process of breaking rocks down right where they sit. This could be physical weathering, like water freezing in a crack and splitting a rock wide open. It could be chemical, like acidic rain dissolving minerals, or even biological, like a tree root tearing a boulder apart. But notice the catch here, nothing actually moves. Erosion, on the other hand, is the actual transportation of that broken material. It's when water, wind, glacial ice, or ocean waves pick up that broken soil and rock and haul it somewhere else. But simply, weathering provides the broken pieces, erosion sweeps them away. And humans have been fighting the negative effects of this erosion for thousands of years. For farmers, erosion literally steals the fertile topsoil that is so necessary for growing crops. So ancient civilizations like the Sindhu-Saraswati used incredibly sophisticated methods to manage water and protect their soil, practices we even see documented in ancient texts like the Arthashastra. Fast forward to today, and brilliant systems like Nagaland's Zabo system utilize these exact steps to fight erosion. They use contouring along hillsides to slow the water down. They build earthen embankments called bunding to hold soil in place. And they cut steps right into the hillsides, they're terracing. These are amazing engineering feats designed to combat that natural movement of erosion and protect human livelihoods.
All right, let's get into Section 3, nature's sculptors at work.
So we have these four main agents of gradation that are continuously lowering high areas and filling in low areas. Running water carves sharp V-shaped valleys and deposits massive, fertile deltas that are incredible for agriculture. Then there's wind. Wind acts almost like a giant sandblaster, carving out streamlined rock ridges called yardangs in the desert, or piling up massive sand dunes. Next up, glaciers. These giant, slow-moving rivers of ice scrape the earth like a bulldozer, carving out wide U-shaped valleys and leaving behind piles of rock and debris known as moraines. And finally, ocean waves. They relentlessly pound the shoreline, carving steep sea cliffs and tossing up the sandy beaches we all love to visit. Just think about how continuous running water acts as this tireless sculptor over millennia. Up in the high terrain, where it flows fast and steep, you can see how the river cuts deep, V-shaped canyons right into the rock. It's powerful stuff. Then, as it loses a bit of energy in its middle and lower courses, it begins to meander, winding back and forth, creating broad plains and depositing rich alluvial soil all along its banks, before finally fanning out into a delta. When you look at the grand scheme of things, water's arguably the most dominant artist on the Earth's surface. And this brilliantly illustrates the ultimate battle taking place right on the surface of our planet. On one hand, you have towering, jagged mountains being pushed skyward. That is tectonic uplift at work, folding the crust upward. But then, right below that, you have smooth, rolling, leveled plains. That is gradational smoothing. Those external agents we just talked about, water, wind, ice, they've spent millions of years wearing down the high points and filling in the low valleys. It's this continuous, epic push and pull between the interior forces building the Earth up and the exterior forces grinding it right back down. But wait, not all the sculpting happens above ground. There is this entirely hidden subterranean world known as karst topography. So, in areas with a lot of limestone, underground water chemically dissolves the rock over thousands of years. This unseen erosion hollows out massive, spectacular caves. Inside, mineral-rich water drips down to form these amazing icicle-like stalactites hanging from the ceiling and stalagmites rising from the floor. And not only does this create a gorgeous, hidden landscape for tourists to explore, but these underground networks are deeply vital for providing crucial fresh water sources to local populations. Which brings us to Section 4, when landforms turn deadly. Now we have to talk about the human stakes here, because these incredibly slow geological processes can suddenly and violently turn into rapid disasters. And honestly, human activity is often the trigger. Think about landslides. Sure, heavy rain can naturally destabilize a slope, but when we add deforestation and unplanned construction on hillsides, we literally remove the Earth's natural anchors. That leads to catastrophic slope failures. The same exact thing goes for avalanches on steep, snowy mountains. Then there are geolofts, glacial lake outburst floods. As global temperatures climb, glaciers melt faster, swelling up glacial lakes until they catastrophically burst right through their natural dams of ice or rock, sending a terrifying wall of water downstream. Even dust storms are intensified when poor farming practices and deforestation leave dry soil completely exposed to the wind. So we really have to hold these two truths in our minds simultaneously. On one side, we have the immense beauty, the sheer awe of studying our massive globe and its incredible geographical diversity. On the other side, we have the terrifying reality of sudden geographical violence. A tragic, textbook example of this is the devastating glacial lake outburst flood that struck the Chamoli district in Uttarakhand in February 2021. The deep, precarious topography that makes those mountainous regions so breathtaking is the exact same topography that can rapidly channel a sudden release of glacial water. And that leads to tragic, devastating losses of human life, livestock, and infrastructure. Which brings us to a foundational takeaway for today's explainer. Understanding how our Earth's surface is shaped isn't just about passing a science test. It is fundamentally about survival. It's about smart city planning. It's about knowing exactly where to build our infrastructure, how to farm our land sustainably, and recognizing where we need to respect the Earth's boundaries so we don't accidentally trigger a disaster. So I want to leave you with this final, provocative thought. Next time you step outside, take a long look around you. Ask yourself, what invisible forces, millions of years of water, wind, or deep tectonic pressure sculpted the landscape you call home? And more importantly, knowing what you know now, how vulnerable is your town when the Earth decides to move? Keep questioning, keep observing, and never underestimate the master sculptor right beneath your feet. Thanks for joining me on this explainer, and I can't wait to dive into our next topic with you.